Hi everyone. Once again, welcome back to my YouTube channel. This is Pawni Raj from SBCE, Department of CSEDS. So the subject is Mathematics for CSE stream. Let us look over the topic Application of area in integral calculus. So in this section we are going to discuss about the sum of applications of area in integral calculus. Let us look over a small introduction on integral calculus. Integral calculus is a branch of mathematics that deals with the concept of area under a curve. The application of area in integral calculus allows us to find the total accumulation of a quantity over a certain interval. It has numerous applications in various fields such as physics, economics, and engineering. So, area between two curves. Integral calculus helps us to find the area between two curves. By subtracting the area under each curve, we can find the desired area. The limits of integration are determined by the points of intersection of the curves. Finding area under a curve. The integral of a function represents under the curve of that function. By integrating the function over a given interval, we can find the total area enclosed by the curve and the x-axis. This concept is denoted by the definite integral symbol with the function and interval specified within the symbol. Calculation of total accumulation. Integral calculus allows us to calculate the total accumulation of a quantity over a certain interval. In real life applications, this can represent the total distance traveled, total sales revenue, or total amount of substances produced. By integrating the rate of change of the quantity over a specific time interval, we can find the total accumulation. Whereas in physics applications, in physics, integral calculus is used to calculate the total displacement velocity and acceleration of an object. By integrating the velocity function, we can find the total displacement traveled by the object. Similarly, integrating the acceleration function gives us the total change in the velocity over a certain time interval. Whereas in applications in physics, calculating the area under a velocity time graph gives us the displacement. Finding the area under a force displacement graph gives us the work done. Integrals helps us to understand the physical quantities and their relationships. Whereas in economic applications, in economics, integrals calculus is used to calculate the total revenue, cost, and profit of the business. The integral of the revenue function gives us the total revenue generated over a specific time period. By subtracting the integral of the cost function from the revenue integral, we can find the total profit. Applications in economics. Integrals can be used to measure consumer and the producer surplus. Calculating the area under a demand curve gives us the total revenue. Integrals helps economists analyze supply and demand dynamics. Application in engineering levels. Integrals are used to calculate the moments of inertia. Finding the area under a stress strain curve helps engineers understand material properties. Calculating the area under a power time graph helps determining energy consumption. Whereas in numerical integration, in some cases, it may not be possible to find all exact expression for the integral of a function. In such situations, numerical methods like the trapezoidal rule or a Simpson's rule can be used to approximate the area under the curve. This method divide the interval into small subintervals and approximate the area using a simple geometric shapes. Whereas application in probability integrals helps us to calculate probabilities by finding the area under probability density functions. By integrating a probability density function, we can find cumulative distribution functions. Probability distributions can be analyzed and understood using an integral calculus. So let us conclude the section. The application of area in integral calculus is a powerful tool for finding the total accumulation of a quantities. It has a wide ranging application in physics, economics, and engineering. By understanding and utilizing the concept of an integral calculus, we can solve complex real life problems and make informed decisions. So let us end this section here. Thank you.